everyone. In this lesson, we're going to continue to solve polynomials, but you're going to learn about the fundamental theorem of algebra. That's going to give you a little bit more information and help you to solve those polynomials. So first we have a review of what complex numbers are. All numbers are complex numbers. We have real numbers and we have imaginary numbers. Included in real numbers are rational numbers and irrational numbers. So sometimes I think it's helpful to just go back and look and remember that when we talk about a complex number, we're referring to all numbers, both real and imaginary. Now, the fundamental theorem of algebra says that every non-constant polynomial with complex coefficients has at least one complex root. And the corollary to that says that if p of x is a polynomial of degree n greater than or equal to 1, then p of x equal to 0 has exactly n roots. So here's some examples of what I mean. If we have x to the first, that's the highest degree term in our polynomial. The degree is 1. We know we have one complex root. If our degree is 2, we know we have 2 complex roots. If our degree is 3, we have 3 complex roots. And if our degree is 4, we have 4 complex roots. So we talked about this a little bit in past lessons. If you have a cubic polynomial, you have 3 roots. If you have a quadratic, you have 2 roots. If you have a quartic, you have 4 roots. And we're just reinforcing it here with the fundamental theorem of algebra. Now, possible combinations of complex roots. Recall from the imaginary root theorem that imaginary roots always come in pairs. So we need to keep that in mind when we examine what types of roots we could have for each kind of polynomial. So let's look at this table. Again, we're looking at a first degree polynomial, and we know that we have one root. If we have one complex root, either real or imaginary, it has to be real because imaginary roots come in pairs. And we know we don't have 2 roots, we only have 1. So if we have a first degree polynomial, we only have 1 real root. That's the only possibility. Now, if we're talking about something like a quadratic, so we have a degree 2, we know we have 2 roots. So we could either have 2 imaginary roots or we could have 2 real roots. Now, for this example, we have x squared plus 1. If I worked that out to solve it, I'd get x squared equals negative 1. I take the square root of both sides, and I'd get x equals plus or minus I. So for this example, we have 2 imaginary roots, but keep in mind we could have 2 real roots. So if I change that problem, let's say I made this x squared minus 1 equals 0. Then I would have x squared equals 1, take the square root of both sides, I get x equals plus or minus 1. So you see what I'm saying? In that example, I have 2 real roots. All right, so it's just giving us an idea of what to expect as we're going about solving polynomials. Now, the next one is a cubic polynomial. I know I have 3 roots, so I could either have 3 real roots or I could have 1 real root and 2 imaginary. Imaginary roots come in pairs. I can only have sets of 2, 4, 6, 8, and so on. So for a cubic polynomial, I either have 3 real or I have 2 imaginary and 1 real. For a quartic polynomial, I know I have 4 roots, so I could have 4 real, I could have 4 imaginary, or I could have a combination of 2 real and 2 imaginary. All right, I hope you're starting to get the idea. All right, so for example number 1, we have x to the 4th. Since we have x to the 4th, we know we have 4 roots. It's possible to have all real roots, so 4 real roots. Imaginary roots come in pairs. So the possibility there could be 2 and 2, so 2 pairs. So we could possibly have all imaginary roots, that works. Or we can have just 2 real roots and 2 imaginary roots. In the next example, we have a cubic polynomial, so we know that we have 3 roots. We could have all real roots, It's not possible to have all imaginary roots because imaginary roots come in pairs, so it would have to be 0, 2, 4, 6, 8, and so on. So this would be not applicable. Or we could have two imaginary roots, which would leave one real root remaining. Now we get to go to the fun part where we're actually going to use that information to help us find all the roots of the polynomial. Now this polynomial is raised to the fourth power, so we know we'll have a total of 4 roots. We're given 2 here. They could be all real roots. We could have 2 pairs of imaginary roots, so we could have 4 imaginary roots, or we could have 2 real and 2 imaginary. Now we're given 2 of the roots. These 2 guys are definitely real, so I'm pretty sure then we're going to end up maybe in this category, or we could end up in this category. So what we're going to do is we're going to use synthetic division. We're going to put the first root in the box, and we're going to reduce down to a cubic polynomial. We're missing the cubic term, so that's going to be 0. We're missing a linear term, so that's going to be 0. And we know we did it right because we got 0 as a remainder. Now we started at a quartic polynomial. We're going to a cubic polynomial. We have x cubed plus 2x squared plus x plus 2. And we've used the root 2. We can now use the root -2. We're going to do the same thing. We're going to put -2 in the box, and we're going to bring down all these values, the 1, the 2, the 1, and the 2, the coefficients of our cubic polynomial. And we're going to continue to do synthetic division just like we did in the first part. And again, we know we did it right because we got 0 as a remainder. We had a cubic polynomial. We are now going to go down to a quadratic, 1x squared plus 0x plus 1. We could write that as x squared plus 1. Now you can use the quadratic formula, but it's much easier to just solve it using square roots, and I'll show you what I mean. The first thing I'm going to do is I'm going to subtract 1 from both sides. I get x squared equals -1. I'm going to take the square root of both sides. I get x equals plus or minus I. So all the roots then would be, well, first of all, we knew it was going to be 2 and -2, but we've also added plus or minus I. And so it worked out to be this scenario. All right, that was fun. Let's try another one. Moving on. We're given 1 root. We have a cubic polynomial. If it's a cubic polynomial, we know we'll have 3 total roots. They could be all real. It's not possible that they're all imaginary. Not applicable. Or we could have 2 imaginary roots, and that would leave 1 real root left over. We're not sure what the scenario is going to be. We're going to put 2 in the box and do synthetic division. All right, we started at a cubic polynomial. We've now reduced it down to a quadratic. That would be 1x squared plus 0x plus 4. I'd prefer to write that as x squared plus 4 equals 0. And again, instead of using the quadratic formula, we can use the square root method. So we're going to subtract 4 from both sides. We're going to take the square root of both sides. All right, final answer for this then would be that our roots are 2 and plus or minus 2i. That worked out to be this scenario here. Okay, we have one more to try. Oh, this is a good one. So I would suggest that you pause the video and try this on your own. Definitely a math high possibility here for you. You will be using synthetic division 3 times before you get it down to a quadratic, because we're starting out at x to the 5th power. So go ahead and give it a try and come back when you're ready. This polynomial has 5 roots because our highest degree is 5. We could have 5 real roots. That's a possibility. Since 5 is an odd number, we couldn't have all pairs of imaginary roots. This guy would be not applicable. Or the other possibilities are we have 4 imaginary roots and 1 real root. Or we could have 2 imaginary roots and 3 real roots. We're not sure what's going to show up. I'm going to start out by putting 2 in the box. I'll bring down all my coefficients. And I know I did it right because I got a 0 as a remainder. We started at the 5th power. We're going to reduce it to the 4th power. And now we're going to again use synthetic division. This time we're going to put -2 in the box, and we're going to use our reduced polynomial coefficients. We know we did it right because we got 0 as a remainder. We started at the 4th power. We're reducing it now to a cubic polynomial. I'm going to use my last root, which was 3, put it in the box, use my coefficients of my cubic polynomial, all right, it's now reduced to a quadratic. We have x squared plus 0x plus 2 equals 0. You're welcome to use the quadratic formula, but I prefer, in this case, to use the square root method. I'm going to subtract 2 from both sides. I'm going to get x squared equals -2. Take the square root of both sides. I get x equals plus or minus I root 2. Final answer here, I knew my roots were 2, -2, and 3. I proved that using synthetic division. And the other 2 roots were plus or minus I root 2. Okay, that's the end of the lesson. I hope you enjoyed it. Good luck and have a great day.